Hi, I'm back. Um, in the last session, we have dealt with a lot of concepts actually about the modeling, the ANOVA, ANCOVA, and ATI model. So I want you to watch the video 7 regression to ANCOVA pages 5 through 33 repeatedly. Okay. So without the interaction effect, we have two main effects here. The two main effects. One is SES, covariate, continuous variable, and the G10 urban is urbanicity level, urban, suburban, and rural, so categorical variable. So without converting this categorical variable into dummies, we can simply run the analysis using the tab GLM menu in the SPSS. So when we use the GLM menu, we need to use this categorical variable and the covariate, continuous covariate, and we can also add the interaction effect between two. But since in the last session, we know the interaction effect was not statistically significant, but we simply use the ANCOVA model without interaction effect here. So let's think about how we can interpret this table. And corrected model is ANOVA, the overall model, right? Overall model. So once we have two important X variables here, one is a categorical variable, the other is covariate, continuous, SES, X variable, then the model, overall model is statistically significant. And when we see the individual slope, we can find out SES is statistically significant, and urbanicity is also statistically significant. But inside this urbanicity, we have multiple categories, right? So which one is significant? Which one is significant? We do not know that information according to this table. Anyway, so SES is statistically significant. So which means, so what we reject the null hypothesis for this. What is the null hypothesis? Beta 1, so beta SES is 0. That is null hypothesis, right? Since the p-value is smaller than alpha, 0.05, we reject the null hypothesis. Therefore, SES is non-zero slope. Non-zero slope, okay? G10 urban, this is also statistically significant, so we reject the null hypothesis. We reject the null hypothesis. What is the null hypothesis? Beta urban is 0, but we reject that null hypothesis, so G10 urban is non-zero slope, okay? This is also optional slide. You see the degree of freedom for between group and X covariate and within group. Within group means within variance, within subject variance. So this is F formula. So SST equals SSB plus SSX, sum of square between sum of square covariate X and SS within. This is very familiar. This is very familiar, right? Do you remember the SST equals SSR, sum of square regression plus SSE, sum of square error? Do you remember that? That is from the, sum of square total, the special video. Here, instead of sum of scale regression, we use the sum of scale between because this is kind of ANCOVA form notation. SSX, we have two different main effects. SS between is a group factor. SSX is a covariate factor. And SSW is kind of SSE, error. So SSW is SS within. Do you remember the example that I was talking about? Subject, within subject, and between subject. So we have 30 people in our class. And there are females and males, right? So there must be some kind of variation between female group and male group, which is called between subject variation. Also, within one gender group, within female group, there must be some kind of within variation also. Likewise, inside the male groups, there is also within group variation, right? So inside one group, one gender group, it is kind of within, in this mentality, within variation is regarded as just the errors, which is not captured by the model. You know what I'm saying? So if you want to decrease the amount of the errors, you really need to have a good X variables in your model. Yeah. Again, if you add more covariates here, you're going to have a different kind of SSX in the model, right? Then your SSW will be smaller. Likewise, your SSE will be smaller if you add more X variables, okay? As long as they are good variables, okay? All right. In running the ANCOVA, we need to get some other statistics. If we get both descriptive statistics via the options button and estimated means using the windows at the top of the option button window. So this is about SPSS thing. We will see the difference between the raw and adjusted means. Also, to get the slope of the covariate, we need to select parameter estimates on the option button. So I will post a separate video for this GLM steps in SPSS because this is about SPSS procedure, so I better show some kind of visualization. Okay. So that would be about how to generate SPSS outputs using GLM menu. So it can be used for your research paper analysis, okay? The estimated means will have a footnote telling us that they are adjusted and also telling us what the mean SES value is for our sample. We will only look at the marginal means for the G10 urban factor, not overall. Okay. Let's go back to find out what the slide set was talking about. Here. So in the GLM menu, once you click all the options and then, estimated marginal means, you click the estimated marginal means, then it will show this table. This is the categorical variables. And with this, the common mean of covariate, it will show the adjusted mean. In the option, there is one option, descriptive statistics. And that descriptive statistics table show naive mean. For the public school, a naive mean. And for the private school, a naive mean. These adjusted means are different from the naive means. Then you're going to compare, the adjusted mean with the consideration of the covariate is different from the naive mean. You will see that once you run the GLM analysis. Okay? All right. Okay. The urban and suburban principal leadership adjusted means are slightly lower, but the rural adjusted mean is higher than the raw mean. So this descriptive statistics shows urban is 1.18. This adjusted mean, urban is 1.14, is slightly lower than this. How about suburban? Naive means for suburban is minus 0.227. Adjusted mean for suburban is minus 0.292. Rural outside, naive mean is minus 1.2. Rural outside, very big difference, minus 0.86. Okay, very, very difference, okay? Here, it looks very, very different from different between urban and rural. But here, how do you think so? The gap between urban and rural by adjusting the covariate mean, then the gap between urban and rural became smaller, right? So the adjusted means plot, the plot is shown from the GLM menu, but naive mean wouldn't be shown in the SPSS. So if you want to contrast the two different types of means, you can use Excel, you know. Next, we need the slope and the estimated model SPSS gives us. So in the GLM menu, you click the option and then you click parameter estimate. It will show this one. So you saw the G10 urban was statistically significant, but you don't know which category is statistically significant. So this parameter estimate shows each category. So G10-1 was urban. So urban has this unstandardized slope, and t-test value is larger than 1.96, and this p-value is smaller than alpha 0.05. This is statistically significant. So urban is non-zero. Urban is non-zero. However, okay, this suburban, even though the slope looks like 0.571, since this is what? Larger than alpha level, we regard this as zero, because this is not statistically significant. Reference group is rural, so there is no p-value, okay? The slope for SES is clear, but what about the other values? These are the slopes we would get if we ran a regression with dummy variables for urban and suburban schools. So the estimated model from SPSS is y hat equals minus 0.933 plus 1.436 covariate plus 2.007 urban plus 0.571 suburban. So these values are from where? Here. You know how to make estimated regression line, right? So this is a slope for urban. This is a slope for suburban. So look at these numbers. You can see everything here. Okay. Later, we will see how we can use this model to get the adjusted means for the three groups. This is the ANCOVA table. This is run by regression tab in the SPSS. But test of between subject effects table is from GLM model. Okay. So coefficient table is individual slope test run by regression tab. And parameter estimate, this is from GLM model. So this is the same as this. Finally, we call the estimated model is this. We will use this model to do a check on the adjusted means. To do so, we substitute for SES in the equation the value of the mean SES score, that is X bar. This is dot means overall group 0.049. So 0.049 is plugged in the regression. So you want to have ruler for the estimated model. Then since ruler is a reference group, you plug 0 and 0. And then you plug the common mean of covariate SES here. And you got this number for mean of ruler. This mean is shown in the estimated means above. The end. Thank you. It was a tough topic, but I'm very proud of you. You complete the ANCOVA model. See you next time.